All right, let's take a look at the second example here. So this one, I'm going to show you a slightly different way, almost the same, but this way is if you're having some trouble with figuring out based on n behavior and multiplicity of zeros and so on what's going on, this is an easier but slower way to get the correct answer. So let's jump in and take a look. So for this one, our inequality is x plus 3 over x plus 1 greater than or equal to x minus 2 over x minus 3. And so we can cross multiply the x minus 3 up and the x plus 1 up. And if you believe that, then I have some swampland in Florida to sell you. We cannot cross multiply up. Why can't we cross multiply up? That's right, because we don't know whether x minus 3 is positive or negative, and so if we multiply by it, we both have to switch and have to not switch the sign. So we can't do that. Whenever we move something, we need to add or subtract it. So I'm going to get x plus 3 over x plus 1 minus x minus 2 over x minus 3 greater than or equal to 0. All right. Now I want a common denominator. So I'm going to have to multiply by the opposite fractions denominator in the numerator. And this one will get x minus 2 times the opposite fractions denominator of x plus 1. And the new denominator will be the two old ones multiplied together, greater than or equal to 0. And now we can flesh this out and expand. So x squared minus 9 minus x squared minus x minus 2 all over x squared plus x minus 3x is minus 2x minus 3 greater than or equal to 0. X squared minus x squared is 0. Minus negative x is positive x. Minus 9 minus negative 2 is negative 7. So there we go. And for this bottom part, we actually probably want to keep it in factored form. So I'm just going to revert back to the factored form up there. Okay. And so now we have, a slightly out of focus camera. There we go. So now we have x minus 7 over x plus 1 times x minus 3. So we can see very quickly here that our zeros are at x equals 7. There are no holes. And for vertical asymptotes, we have a 1 at negative 1 and also a vertical asymptote at x equals 3. Okay. So if we set that out along our number line, we go, okay, up here at 7, we have one. At 3, 7 is 0. At 3, we actually have a vertical asymptote. So that's 3. There's 0. Nothing's happening at 0. And then at negative 1, we also have a vertical asymptote. Okay, so we can go and look at this and talk about end behavior and so on and what's above and what's below. That is definitely the fastest way to do it. And if you're comfortable doing that, that's what I would recommend. But there is an easier way, although it takes a little longer. And that way is to just try subbing values into the function and picking your values in each of the ranges that you want. So I'm going to pick one value that's greater than 7. I'm going to pick one value between 3 and 7. I'm going to pick one value between negative 1 and 3. And I'm going to pick a value below negative 1. You can pick literally any value in these ranges and it will work out. The ones that are easiest to calculate are usually the ones that are close to 0 or closest to 0. So out of all the numbers above 7, and I'm going to pick whole numbers because that makes the calculation easier. So out of all the whole numbers above 7, which one is closest to 0? Well, it's 8. So I'm going to say f of x, let's set that to be our function, x minus 7 over x plus 1, x minus 3. And if I do f of 8, what do I get? Well, I get 8 minus 7, so that's 1. 8 plus 1, so that's 9. 8 minus 3, so that's 5. So that is 1 over 45, which is greater than 0. So out here, the function is positive. It is above 0. Between 3 and 7, what whole number is closest to 0? That's 4. So we're going to calculate f of 4. 4 minus 7 is negative 3. 4 plus 1 is 5. And 4 minus 3 is 1. So there we go. Negative 3 over 5. That is going to be less than 0. So in this section here, I like to put it below. Some people like to put it above, negative sign. So the function is negative between 3 and 7. Between negative 1 and 3, what integer is closest to 0? Well, the answer to that is just 0. So we'll calculate f of 0. We get 0 minus 7, which is negative 7. 0 plus 1 is 1. 0 times negative 3 is negative 3. Negative 7 over negative 3 is 7 over 3, which is greater than 0. So in this section here, the function is positive. And then we look for the numbers on this range. Negative 2 is the whole number closest to 0, or the integer, I guess, technically closest to 0. So f of negative 2 equals negative 2 minus 7 is negative 9. Negative 2 plus 1 is negative 1. Negative 2 minus 3 is negative 5. And so we get negative 9 over positive 5, which is less than 0. And so in this section, the function is negative. Now, oh, and I guess I'm off the bottom there. So as you look at this, you might be tempted to think that it always just switches from positive to negative to positive to negative. That's not true. In particular, if any of your factors, either in the numerator or in the denominator, have a multiplicity, so have an exponent on the factor that is even, then this probably isn't happening. But it actually gets a little more complicated than that, because you can have situations where you have wholes and vertical asymptotes. So you do need to be pretty careful about it. But if you want to count multiplicity, so let's say, we'll look at an example here I'm going to make up as we go. So x plus 3 times x plus 5 over x plus 2. So for this function, every time you hit either a vertical asymptote or a 0, it's going to change sign. Multiplicity on all of these is 1. If we change it to like that, at negative 5, it's going to change sign. At negative 2, it's going to change sign. But at positive, or at negative 3, it will not change sign. It will keep the same sign because we have it squared. What if I then do something like this? Well, now it's not going to change sign at 5, or at negative 5. It will change sign at negative 2. It will not change sign at negative 3. And that's because we kind of count the multiplicity for these purposes, the top and bottom together. So this is an exponent of 1, this is an exponent of 1. 1 plus 1, or really technically 1 minus 1, is 0. So that is even multiplicity for x plus 5 overall, and therefore it's not going to change sign. And we can even get stuff like, if we added x plus 3 to the denominator here, now we have 2 minus 1, so the overall multiplicity of x plus 3 is 1. So now it would change sign at negative 3. So if you find that complicated, and I don't blame you if you do, you can just test out a point in each of the ranges, see whether it's greater than 0 or less than 0, and fill in accordingly. But if you like to use this multiplicity idea to speed things up and know the end behavior, you're welcome to do that as well. So final solution here in intervals would be, let's see, we are looking for greater than or equal to 0. So that is going to be from -1 to 3. And we don't include either one, round brackets, because they're vertical asymptotes. The function doesn't exist at -1 and 3. There's no y value for these x values. And then we unite that with from 7 on up to infinity. And we use a square bracket at 7 because at 7 the function has a 0, so it is equal to 0, so that is part of our solution. At -1 and 3 with the vertical asymptote, the function's not equal to 0 there, so we don't get the asymptote. Okay, so I'm going to dive into the last question here, which is the economist for a sporting goods company who is estimating revenue and cost functions. And for those of you who haven't taken business courses, revenue is the total amount of money that a company brings in. Cost is the total amount of money that a company spends. And profit is revenue minus cost. So whatever they bring in, take away whatever they've paid out is their profit. So in this case, we have the revenue function, r of x equals -x squared plus 10x. The cost function, c of x, is equal to 4x plus 5. And therefore, the profit function, p of x, is going to be equal to revenue minus costs. And if we simplify that down, we get -x squared. 10x minus 4x is 6x. And then subtract 5. So there we go. And so then we're told that the average profit, which is the profit per snowboard, is AP of x equal P of x over x, which is -x squared plus 6x minus 5 over x. And the last thing to notice in this question is that x is number of snowboards produced in thousands. So if x equals 1, that means 1,000 snowboards. If x equals 7, that means 7,000 snowboards. So we want to determine where this average profit per snowboard is going to be greater than 0. Okay, so let's dive in. First thing we're going to do is we are going to factor this. So I'm going to take the negative sign out, x squared minus 6x plus 5 all over x, and then we want to factor that quadratic, and that is going to give us x minus 5, x minus 1, and we're all over x greater than 0. And now we find our zeros, our holes, and our asymptotes. So the zeros are at 5 and 1. The holes don't exist. And the vertical asymptotes are at x equals 0 only. So now we can draw a quick sketch of the graph. At 5 we have a 0. At 1 we have a 0. At 0 we have a vertical asymptote. And we can test some values in between these points and see what's happening. So if I pick 6, 6 minus 5 is 1, 6 minus 1 is 5, 1 times 5 is positive 5, positive 5 over 6, and then we have this negative sign which makes it negative 5 over 6. So f of 6 is negative 5 over 6, which is greater, oh, no, less than, see if I can do the correct thing here, less than 0. Then we can pick between 1 and 5. Well, 2 is the closest integer to 0 in there, so I'm going to calculate f of 2. So we've got negative 2 minus 5 is negative 3 times negative is positive 3. 2 minus 1 is 1 times positive 3 is 1 over 2 gives us 3 over 2, which is greater than 0. And then in here between 0 and 1 there are no integers, so we're going to have to pick a decimal. So I'm going to pick 0.5 or 1/2. So 1/2 minus 5, and the exact number doesn't really matter because all I care about is greater than 0 or less than 0. So I can just look at the sign. So 0.5 minus 5 is negative. 0.5 minus 1 is also negative. So this is negative times negative times negative, which is overall negative, divided by 0.5, which is overall positive. So negative divided by positive gives me a negative, and so this is going to be less than 0. So negative in that section, positive in this section, negative in this section. And over here, if I sub in negative 1 minus 5, that's negative 6 times negative is positive 6. Negative 1 minus 1 is negative 2 times positive 6 is negative 12. Divided by negative 1 is positive 12. So f of negative 1 is 12, which is greater than 0, and so we get positive there. And then we can conclude, therefore, the average profit is positive when between 1,000 and 5,000 snowboards are produced. Ooh, try to spell boards correctly. Snowboards are, move this up just a touch, produced. All right, so that is it for today. Hopefully that will help you out. I'm happy to take any questions. And on Friday, we will be back to our regular live lessons. Thanks a lot.